Today's gonna be shorter because I have an exam. But yeah. Okay, perfect. I have an exam at noon, so. I remember the music was pretty loud last time. Yeah, I'll make it a little bit quieter. Okay, there you go. Let me do. What's up, brain? Alright, let's started stream a little late. I had some stuff to do this morning, so. How was your exam on Monday? My exam on Monday was chill. I'm waiting for it to be graded. But I have an exam in a couple hours, and then I also have an exam this weekend. Still waiting for the one from Monday to be graded. It's probably gonna take a minute. Yeah, they still haven't graded it. Alright, whatever. How long are you shooting today? My exam's at noon. So probably like 4 hours. Something short. Short and quick. Pause. taking so long? Okay, try that again. Oh, is this airdrop complete? Oh, my iPad is tweaking right now. I'm gonna change the camera. The sun's still rising. My freaking AirPods, bro. Alright, bro. Oh, import. Okay, files. Perfect. There we go. Finally. Great. Plug. My laptop. Dude, that's ridiculous. I guess I'll put it on the right side. Let me switch these. Okay. Bro, these headphones are like actually useless. They just keep disconnecting and reconnecting to my devices. It's so annoying. It's like there's no point in wearing them. It's ridiculous. Yeah. Dang, now my hand's kind of wet. I have these blueberries. Okay, that should be fun. initial energy is just going to be potential energy, so you have no velocity. And the final energy is going to be all velocity, or all kinetic energy. Alright, so we get E equals root 2gh. Okay, now she's actually underwater. It's just draw a body. Right, let's do like a circle, I guess. A mass M. So we have the force of gravity. And we say equal and opposite to that is the buoyant force. Okay, so she's gonna have some initial velocity. Right, it's going downwards. And in this current setup, there's no forces, so she would just be going downwards forever. But we say that there's this drag, this viscous force, that is opposing her motion. Okay, so it's gonna go up. And this is just magnitude. So we're gonna define up like this direction. That's minus y. Okay. We're defining the upwards direction as minus y. Let's take equilibrium asking. So it wants us to find it in terms of x. So which turns into believe that's right. V equals V naught E minus P by Mx. Yeah, should be good. C, solve for the divergence vertical depth. Okay, so we want to solve for x. Oh, well, let's just go back in time and use this this part of the equation. Oh, actually, no, we shouldn't do that. It wants it in terms of t, right? Yeah, okay. So we have to do this. Suppose e to the b by m. Right. I'll just integrate. Right. Okay. Wait a minute. Do we have to? Oh, you know who's an idiot is me, because this is not right, actually. This is, minus 1. Okay, I should just write my balance. Right. Oops. Using M over B. Oh, wait. Yeah. Some early stream. Yeah, I guess it's pretty early. What's good, Paul? How did your exam go? It was chill. Back to streaming more frequently? I don't know. Possibly. Okay, let me do this now. Oh no, it's not necessary. Oh yeah, it is. Yeah, it is. Sorry. Okay, this is what I get. We can actually just like solve for this, like, right? We should have m by b times b by v naught t plus 1 minus m by b equals v naught t. Right, we get these cancel. We got m by b. V naught t equals v naught t, of course. Okay, perfect. Well, is that all the question I was asking? Yeah. Okay. Okay, show that the force is conservative. Okay, this is actually, I actually need the equation sheet. So this is chance. No, I had to. This is for the second part. None of these are helpful, actually. Were you outside before studying? I wasn't outside, but I was out of my room. I was doing stuff this morning, and then I started studying. Okay, so we want the force. Okay, so we're saying this is conserved, so that means that dE dt. This is what we want to prove. We want to show this. Sounds like someone's awake. Okay, so we're told that this is 0. So we're saying okay, that's what we want to show to make this whole thing true. This is equal to just do this real quick and then I'll come back to it. Okay, that's all I needed to prove. This one's pretty straightforward. I'm just saying L dot equals torque equals R cross F. And this should be pretty simple actually. Because force is central. Pretty sure if a force is central, then R and F are parallel. Yeah, that's right. So if a force is central, this just means it's radial outward. And L is conserved. Great. Damn. When did you wake up? I woke up at like a little before 6. I don't even remember what time it was. It was like 5 something. But I accidentally woke up. My alarm was set for 6. I'm in Illinois. Hello, Aidan Andrews. RC is in the West Coast, so it is 5 a.m. for him. I don't know what he's doing up, bruh. No, I don't usually wake up at 5 a.m. That would be a problem. I'd be getting too little sleep. It was just this morning for some reason. Yeah, and this can be derived. I mean, fine. I'll derive it. Fine. It's like the simplest thing ever. This is minus G. And shouldn't there be a 2? Because it's not needed, huh? Wait, there really should be a 2 here, actually. Okay, it's fine. I'm not driving. elements inside. So we know rho. On the inside we have rho, which equals mass over volume, right? Just put tau. Mass per unit volume, so we're going 4/3 pi r cubed rho. Over R. Do we have to be careful about where we're integrating from and to? I actually think so, right? Because, yeah, we actually have two gravitational potentials, so. It's a minus minus again, so. Oh, well, actually, outside there's no enclosed mass, so it's just gonna be. Wait, why do I not have a negative sign? Yeah, the minus sign should cancel. And then this is from infinity to big R. This is what we should do. Okay. Yeah, but this should just really equal. Yeah, but where do these minus signs come from? I guess that's where that came from. So we have minus GM. I don't know where that 2 goes, bro. It doesn't make any sense at all. Sorry, that's just weird. Okay. Then we can do this. We get G. 2G pi over 3 rho outside of it's just big R squared minus little r squared. kind of doesn't make any sense. Okay, can we go back to part A? I should be... This should be able to be derived, bro. Wait, is it RDR? No, then we have natural log. That doesn't make any sense. Yeah, I'm confused where this -2 goes, right? So GM over -2R. I'm not tweaking, like that's how you integrate that. Oh, no, that's not how you integrate. What am I talking about? Bro, I'm cooked. Yeah, this is right. This is right. Obviously, there's no, this is 0 minus, oh no. Minus GM over big R minus 0. Wait, this should just be a little r, bro. This is our final answer for A. Okay, B. We're somehow getting a different answer though. Yeah, so this is right. We got the right second integral. But our first integral is wrong. Because we shouldn't have an M. What we're using M as M enclosed. Oh, you know what? This is a square. Oh, yeah, that's fine. It doesn't change my answer at all, actually. Yeah, what? It doesn't change my answer whatsoever. Yeah, 2 pi. Okay, so this is the right final answer, but you can do further simplification if you recall that our mass equals 4 pi. So we have 2/3 g pi rho squared. Right, g pi rho is gonna be big R because we're at the radius. Is like the full mass of the entire object. So it's just gonna be R squared. Yeah. And then yeah, if we distribute 2/3. Wait, 6/3. Yeah, okay. And then we can factor out. It should be. Whatever, leave it. Okay, what's problem C? Small test is mass from a drop from mass into the hole Okay, so it's simple harmonic motion. Obviously. Okay, so for harmonic motion, we have this sphere, K rods, whatever. So this is dropped right from the surface. So it's gonna go here. And then it's gonna turn around here and go back. And this is gonna keep oscillating forever as long as there's no outside forces. Okay, so we want omega squared equals k by m. T equals 2 pi over omega, right? So we need to find a form for its velocity. velocity is just going to be equal to, yeah, right, so we have ma, yeah, ma equals mg, so you just have a equals g, right, and our g is given by, this is in the middle, so this, squared, okay, so or hat direction, this equals a, or r double dot, and so pretty sure this is k by m. So we just have omega equals root gm over r cubed. So t equals 2 pi. Okay. To continue, this question we were told is given, and this question is so easy, bro. Okay. The particle mass atom is constrained to a moving line in a straight line. Just write this out. Where A and B are positive constants. Position where the potential energy is minimized. Okay, so you oh shoot, forgot to do the. Let me write it this way actually. Equals B by A. Ln A by B, right? Right, because if we write this out like this is minus ln A by B, which equals A e to ln B by A equals A B by A. A is cancelled, we're just left with B. B minus B is 0. Perfect. There we go. We have to check that it's a minimum. Isn't that 2B? And that's greater than 0, so minimum. I think you're supposed to do like Jacobian and stuff, but I'm not doing all that. Let's just move on. This is our answer to A. Let z equals x minus x naught for z is less than, yeah, okay. So this is a Taylor series expansion of u x minus x naught is going to equal u prime x naught, no, It's 2b, right? ln b by a, b. Oh, sorry, no it's not, because we have this annoying thing. Right, that's just some constant, essentially. Plus, we know this is 0, right? It's like the definition of x naught, is why we have x naught. The second derivative is 2b over 2, so b times x minus x naught. So if we just say this is some constant c, we say k equals b, then we have u x minus x naught roughly equals c plus k z, oh, squared. Okay, that's all we needed to show, right? And we just, yeah, okay. Okay, find the period. So, omega equals k by m. And then t equals 2 pi omega. So t equals 2 pi m by b. Just a root. 2 pi root m by b. Okay, that's it. So I had trouble figuring out where this came from. Like, I knew this, but other than having it memorized, I don't know where that comes from. This integral, I never got the final form that is supposed to be achieved. Okay, it's fine, we need that. Oh yeah, this, how are these two equal? I know all the other parts, but how are these two equal? And this is like the easiest question I've ever done in my life. Okay, I guess we can check my answers, even though I know they're all right. B equals root 2gh, right? Velocity equals this nonsense. V naught e to minus b by mx, yep. C equals m over b ln b by m v naught t plus 1, yep. Yeah, they use the same exact thing. Yeah, so I just don't understand where this comes from. You're saying the derivative of kinetic energy equals mv dot v. Oh. Wait, does that kind of make sense actually? Because, like, are they just saying dv squared dt equals d, yeah, like if we have 1/2, then this is just going to equal v dv dt. Is that what we're saying? But then why do we have this leftover dv dt? Do the derivative like that. Whatever. My answer's right, so it doesn't matter. No, it does matter. It does matter. Wait, what is this, actually? that? Wait, am I wrong here? Oh, I am kind of wrong actually. Yeah, I got mixed up. Wait, did I? What do we say? V dot F plus grad U. Wait, that's stupid. F dot grad U, F plus grad U is 0. Like, that's trivial, but where does that even come from? Yeah, the solution's just making shit up. I got the right answer though, so. This one's super easy. Like, R cross F is 0. Like, we know that. Right. Minus GM over R. Okay, this one I have. My final answer doesn't match theirs, right? But my answer's right. I don't know how they did their algebra. Like, what? I don't know. Yeah, that's so stupid. I don't get that. Okay, but we're saying G, little g is equal to G 4/3 pi rho G R R hat. Yeah, so we get the same there. Yeah, we got the same there. From a reference point to the point of interest, infinity to R. Yeah, we have that obviously. I don't know why he has minus signs. Wait, it literally makes no sense. Wait, why is this positive? Wait, this actually makes no sense. I think their answer's wrong. Oh, wait, look at this. Why'd the minus sign just disappear here? Wait, they're like actually wrong. These should both be plus. You should have minus. And same with this. You should have minus. Yeah, literally minus, bro. Like, what is he talking about? Or minus. Yeah, that's stupid. This guy's an idiot. No, he's not actually an idiot, but wait, why do I still get a different answer? Bro, these are like the easiest integrals of all time. How are they possibly different than what I got? Let's do his integrals and see what we get. His incorrect integrals. Or her. You never know. Do we want to? Yeah, it's gonna be minus. So minus GM actually gonna be positive. Yeah, see, his answer's wrong here too. Like, this is positive. Bro, are we serious? Do I need to write this out? Like, this is the integral, bro. Bro, what's the integral of 1 by r squared? It's 1 by r. It's minus 1 by r. Yeah, this is all sorts of messed up, bro. I guess it's fine if he makes a minus sign come out of nowhere, then it's fine. Wait, no, that doesn't work actually. Okay, fine. Let's say, okay, so he forgot his minus signs here, bro. We know that. So then we do have a negative here. So then we have gm by big R. Right, because infinity is your lower bound, so it's just minus 0. And then for this integral, you just get r squared by 2 times all this nonsense. And it's going to be... it's actually a bunch of stuff, but okay, we gotta keep track of these minus signs, bro. Well, there is no minus sign actually. It's fine. We can make a minus sign by doing r squared minus r squared. Okay, so then minus 4 pi, this is 2 pi, 2 pi over 3 rho g. I'm just going to go outside of this. R squared minus r squared. Okay, and if we plug our definition for rho. Oh, wait, I plugged in, what did I plug in? I plugged in mass, not rho, that's why. Okay, this guy plugs rho back in. Okay, that's fine. Rho equals mass over volume, so it's just m by 4/3 pi r cubed. But then where does this r cubed go? Are we gonna do big R cubed, right? Yeah, because we need the mass of the entire thing. Okay, so we get minus 2 pi over 3 will cancel out. We're just gonna let it left with a 2 in the denominator, 2r squared. With gm. Outside of r squared minus r squared. And then if we factor out an r squared, oh sorry, r cubed, yeah, r cubed. And if we factor out an r squared, then we get gm minus gm. That's how they got their answer. Perfect. Okay, that makes sense. Okay, so his minus signs were all messed up, bro. Like here, I literally just made a minus out of nowhere because his answer was wrong. And we had to add these minus signs here. Okay, I see. Yeah, my answer is right. What? Oh, wait, what does it ask for? Oh, how long does a mass take to reach the other side? So I guess I actually didn't get this one right. Well, I did get it right, but this is T full, like a full oscillation. Yeah, my fault. My fault. Okay, he's right. Yeah, I don't get where this acceleration comes from. He just pulls out of nowhere. I used it from, I also pulled out of nowhere. Just copy and pasted it from my memory. Okay, x naught equals ln a by b. K equals b. Z equals x minus ln b. Wait, z equals x minus ln a by b. Oh, that's fine. Yeah, that's right. Yeah. Yeah. X minus x naught. Yeah. 2 pi m by b. Okay. So now we need to ask ChatGPT about just those two things. Okay, yeah, how does that make any sense? Yeah, but then we're still not, we're only treating one side of it. I guess it's fine. Oh wait, no, this would eliminate the dot product. If I did dv squared by dt, and I got this, we would just have m times this. There would be no dot product. Yeah, no. Where does that come from? I don't get that at all. Yeah, this is actually wrong. That doesn't even make sense. And then our next question was about, what was it about? It was about this. R cubed What does this equal? Frac GM by R squared, right? Minus GM by R squared R hat. The main thing is just this. I don't know where that comes. I don't know where the R cubed comes from. That's the main thing. Okay, let's see what the answer to this question is. Question: choose a product rule applied to the dot product. Okay, so I should just know this then. Mass of the constants with kinetic energy. Yeah. Equals V dot V plus V dot V dot 2V, yeah. 2V dot V dot, yeah. It's fine. Oh, I see. It's really the product rule of the dot product. Seems so stupid. Why is it even necessary? Questionable. Okay. Now that makes complete sense. Done. That's easy. Okay, let me write that out explicitly then. How should I do this? I should note everything down. Yeah, the M can be on either side, it doesn't really matter. Wait, dV dt. Wait, now I have another issue actually. V dot. Oh, V dot. This is V dot. Yeah, from the product rule. Bro, can I get an eraser, please? Oh yeah, this is V dot. So this is just the product rule. It's d V dot V. Wait, no. That's stupid. Yeah, I mean, that's simple enough, bro. Okay. Oh, I actually do have another question about that. Okay, but let's move on to 3C. Let's see real quick. Great eye there shows up because it's inside a uniform mass. But the shell moment. Okay. Okay. Substituting gives what? What? Okay. That's kind of stupid. Okay, so we're saying these things I do know. Like we're saying m enclosed equals 4/3 pi r cubed rho, right? Thus rho equals m 3m by 4 pi r cubed, right? G equals minus g by m enclosed divided by r squared. And r hat. Okay, so we're saying m enclosed equals pretty much like everything cancels there. Wait, yeah, this makes no sense. That all cancels out. What are we talking about? Wait, where did it plug where? Express rho in terms of m and r. Great. Substituting what where? Wait, am I rebooted or what? Is UIUC on fall break? Nah, bro, it's October. What app are you using to draw? It's Notability. Why is your face so red? I think it's just from the sun. I can change the camera angle. Yeah, it's just like the sunlight, I think, is making the camera like that. I don't know. Why am I seeing physics 211 revisit? Marco Roman, you're gonna get banned. Yo, mods, ban Marco Roman. Mikasa Sukasa. Starting my master's degree, that's hype, bro. There's no way typing in LaTeX is easier. Typing in LaTeX makes it actually understand what's going on, bro. If I just have a bunch of slashes and like A equals G is like not the same thing as vec A equals vec G. Right, you're saying the magnitudes are easy, but I want to work with the vector quantities. So it's like technically different. I've just had problems with GPT understanding what I'm trying to say without using LaTeX. That's why. But this doesn't make sense. Substituting what where? How do you spell substituting what where? Any advice for Lynn Alge in doing well in class? Lynn Alge. Not really. I mean, just study, go to lecture, take notes, maybe, if that's what you like to do, take notes. I hate taking notes, so I don't do that, but just study hard, bro. All the classes are the same, bro. As long as you study, you'll do fine. But if you study like a bunch and you don't do fine, then it's typically because you're not studying correctly. You need to ask GPT how to study better. Okay. How do you not take notes? What if the teacher writes on the whiteboard and you're not given a textbook? Well, all courses literally have to have a textbook, pretty much. But GPT knows all the stuff that the teacher's writing on the board anyways, so it's like, there's no point in taking notes. Like, bro. Like, see, bro, this is off the dome for GPT, bro. It's hella light. But to answer that, like, all my classes have textbooks. I mean, even like Physics 325, I definitely don't have to take lecture notes because he posts like the entire lecture. Like, this is the lecture. This is the whole lecture. There's no point to take notes if this exists online. 435 though, they actually post like the worst lecture notes. These typically have like these are fine, but I swear to you, on the board, she does like way more stuff than what is talked about here. But that textbook makes up for it because this book is goated. This book is so goated. Don't you have recorded lectures? Nah, they don't really record lectures in physics. In CS they do, but physics they don't. Yeah, was lecture attendance mandatory? I think, okay, so out of all my classes, we have mandatory attendance. This is all online. Mandatory attendance, no, and no. Okay, so we have 1, 2, 3, 4 classes that are mandatory attendance, and 3 that are not. So it depends on the class, to answer your question. But in physics, typically it is, yeah. Do you take notes when self-studying from a textbook? I do not, no. Bro, it's just like, what is the point of taking notes? I do, like, the homework, I'm pretty much taking notes, bro. Like, when I do the homeworks, like, let's go to, like, look how much writing this is, bro. You think I want to do more writing after this? Bro, like, what? There's also, like, nothing to take notes of, in my opinion. Right, like, as long as I'm studying and doing the homework, like, I'm internalizing the information by doing problems. Yeah, I mean, I don't know. But that's also just me. Like, my learning process does not involve needing to take notes. Like, some people do. Which is, like, fine, but, like, I don't. So, I don't. I actually hate taking notes. It's, like, the worst thing ever. But I see some people show up to lecture with, like, some crazy, colorful notes. And I am quite envious. Like, if I had that, it'd make my life a lot easier. But instead, I'm scouring the textbook and asking GPT a billion questions. But that's what works for me. I feel like when I take notes in lecture, like, I don't actually, like, pay attention. I feel like I'm just, like, scrambling to write what the teacher writes on the board. And then I don't end up actually understanding anything. Like, when I go to lecture, like, I don't intend on memorizing everything verbatim, but I do understand, like, the concepts, because, like, I'm actually engaged. This is iPad mirrored, notability, iPad mirrored. Look, Aidan's iPad. Okay, I'm gonna go back to work, so at least for a couple minutes. Okay, let just read this, what it says. Constant, whatever, bro. Yeah, so this is the formula. I have this on my paper. Right here. Write the enclosed mass in terms of density. Okay, perfect. We did that. Substitute this into step 1. Yeah, that doesn't give you anything to work with, bro. This is what I had in part A. Does he sub rho back in? No way. Oh wow, he subs rho back into G. Oh, and you get G over R cubed over R hat. Oh, that's what you do? It's a double substitution. Wait, when you sub M enclosed, you should have R cubed. Oh, you're saying this is... Oh, this is little r. I'm an idiot. That's why I'm wrong. M enclosed is little r. Okay, so that actually does make sense now. Yeah, okay. It actually is K by M. Minus K by M, right? Because that's what we use for angular velocity. At least that's what I did, but I don't even know if that's right. Okay, so yeah, this makes sense because the mass encloses like your Gaussian surface, right? Like, so it has to depend on little r because you don't know how much it's gonna be. But rho is dependent on big R because you know it's dependent on the mass of the total object. Right? That actually makes sense. Alright, bro, like, this doesn't take that much thinking. Yeah. Okay, perfect. And then, what other question did I have? What was that? What was I asking questions about? V dot M dv dt is V dot F. And V dot F equals 0. Yeah, maybe that was the question I had. In 2A, why is V dot minus grad U. So you're saying grad U dot V equals 0. I still haven't made my equation sheet. Would you agree that it's better to skip mandatory attendance? Are you high, bro? Mandatory attendance? So you're gonna lose free points. Bro, mandatory attendance has to be the most free, like, points for your grade of all time. But like, you're telling me 10% of my grade, all I have to do is show up to class? Like, yeah, right, am I missing class, bro? That's crazy. Yeah, right. I'm gonna get a B plus instead of an A minus because I missed one lecture. Like, that would literally never be me, bro. That's incredible. I go to class if both my legs got chopped off, bro. I'd crawl there. You know what BS that is, bro? Getting like a grade lower in a class because you missed lecture. Like, bro, I couldn't even imagine that happening to me. In EU, we don't have that. I think we don't get points for it. We have to be there. I don't get what you're saying. We have to be at our lectures. We lose points. They punish us for not going to lecture. We don't gain points. We just lose. You just lose if you don't go. Right? There's 1,000 total points in the class. If you don't go to class one day, you lose like 5 points or something. It's not going to be that high, but it's probably like 1 point. Okay, short answer, we don't set. Instead, we use dt equals k du dt equals v dot grad u. Why does... Where did this come from? Is this like, should I just memorize this? Yeah, I mean, I could see why this would make sense. Like obviously, that's trivial. Okay, let's highlight some things that we might have to just memorize. Like that. This final answer. That's obviously everyone knows that. For forces central r cross F equals 0, obviously have to memorize that. Point mass. I guess this. No, it's not really that necessary. Rho equals m over tau, I guess. This. Maybe this, I guess. Definitely this. And that. Guess we can write these down. Just for shits and gigs. And this is just like common sense. Yeah, this didn't require anything at all. This was common sense. Okay, this was also common sense, but I guess we can just say, we'll remember that. And I guess we can remember that Okay. So that's it. Let's get our equation sheet. What did GPT say? Big question is just a multivariable chain rule for a scalar field. Oh crap. Why chain? What chain rule, bro? It doesn't really look like chain rule to me. Oh, I guess it is, yeah, I see. Okay. So you're saying V is equal to dx dt, dy dt, dz dt. I don't know what this is, but... So then we're saying partial u, partial y, partial z, dot v. Okay, we should definitely just memorize that, bro. No way. There's no reason to remember that. No reason at all. Okay. Let's ensure we have this shit. Okay, I don't know why it does this stupid formatting, bro. Yeah, it's fine. Just leave it. Okay, so the first thing we have is we should actually really rigid body projectile. Okay, we can get rid of all the orbit stuff. Actually, I mean, it's fun. It's fun. I just won't write them on my thing. Why do we not write? Okay, I guess I'll write it in fundamentals. Where is this at? What do we even say here? I guess inside liquid. Yeah. What do I want to write exactly? Okay. Yeah, this isn't like necessarily always true, and I don't know what the hell that's trying to say. Yeah, I mean this isn't always true, but I guess we can just write it. Well, this also depends on where you set your thing. Bro, what are these errors, bro? Like, I didn't even write this stuff, bro. Like, come on, fix this. I think I'd write LaTeX like this, bro. What is it thinking about? Like, just fix it. Oh, hello? It didn't make any changes. What is this? I'm confused, bro. You're confused, I'm confused, bro. Where are we now, sheet? Didn't help. This is so annoying. Okay, this command's already defined. It says. So what happened to this being fixed, bro? Like, just come on, bro. Just hurry up. Why are you planning? There's no planning. Just hurry up. Gosh, check linter body. Oh, bad. There, done. Stop. What'd it do? Whatever. Who cares? I don't care. Perfect. Okay, and then we need to write. What else do we have on our line? Oh, I have questions here. There's a whole lot of nonsense. Where should we write this? Rigid body. Let me know what we're talking about here, bro. What? What is going on? Is you effective? Yeah, central. But because we also have, like, I wrote this stuff myself, some of the stuff myself. Okay, let me just start writing this equation sheet, bro. Oops, my bad. this equation sheet, because this equation sheet that I have on my computer is just so bad. It's just like literally the worst thing I've ever seen in my life. Bro, I had to turn in my equation sheet for 435, bro. I was tight. I'm in desperate need of some hype music, bro. I'm no longer listening to stream, so there's audio issues. Someone will have to hit me up and let me know. Okay, so the first section of my equation sheet will be we don't need constants. Okay, we can write that. Okay. Let's write concepts. Newton's second law. I don't know, there's really no point to even write it Newton's second law. Okay. Bro, my equation sheet in 435, I didn't even use it, bro. I already had all this stuff memorized. We also had no time. Like, even if I had to use my equation sheet, I wouldn't have had time to do it. We only had 50 minutes for 3 questions, bro. If you know anything about electromagnetism, each question takes like 20 minutes. Okay. So for all conservative forces, we have first and foremost, a conservative force means that R cross F is 0. Right. Yeah, grad cross F equals 0. Yeah. First and foremost, grad cross F equals 0, and F equals minus grad U. Secondly, we have dE dt equals 0. dE dt equals v dot F plus grad U, right? dE dt equals v dot F plus v dot grad U, or v dot F plus grad U. Yeah. Oh crap. I just made a mistake. On my equation sheet. Whatever, I'll know. On the exam, I'll know what I'm trying to say. V dot F plus grad U. Okay, I'll just write a quick note that this is not V dot. Damn. Okay. V is equal to U by M. What is V? What is V? What even is V? What are you talking about? Alright, whatever. Conservative force. I'm gonna write central force here. Did you really not write anything about central forces, bro? Angular momentum. That's so stupid. Okay. I'm writing my own central forces section. First and foremost with central forces. No, not this. This. central force E equals T plus U equals 1/2 m r dot squared plus 1/2 m r squared phi dot squared plus U of R, and U effective equals well, we should write U effective in this form, L squared by 2m L squared by 2m should be R squared, or that is R cubed. Oh no, because we take the derivative of it, yeah, R squared, yeah. Not the antiderivative. And phi dot equals L by mr squared. For circular orbits at radius r, yeah. U prime equals 0. mr cubed, right? Big R. It should be big R. It should be big R cubed. And so T equals 0 and E equals UF. Okay. That should be it for central forces. Oh, I guess we could also write that it's fine, we'll write that in the next section. What time is it? 8:53, okay, we're fine. L dot equals 0. Kinematics. Do we seriously need to write that, bro? I mean, if somehow that comes up on the exam, bro. I mean, like, yeah. There's like no way I have to use these, bro. This is 211, bro. There's no algebra. Okay. Spherical kinematics is given here and here, these two. Right, that's the same thing that he said. R dot R hat, R phi dot phi hat. R dot R hat, R phi dot phi hat, yeah. And A equals this nonsense. It's literally such nonsense. A is such nonsense. This is on my equation sheet, but I might as well write it in case. I don't even have enough space to write A on that line. Okay. And then give our acceleration. Bro, we barely even have enough room to write on this line. It's OD long. Okay, perfect. That should be it for concepts. Okay. Central force. We already wrote E equals T plus U. We already wrote U effective equals L squared by 2mr squared plus U R. Yeah. E equals U effective if R equals R. We already know L equals the size of L. equals MR squared phi hat, yeah, or phi dot, yeah, we already wrote that. Circular orbit. Yeah, so you just have to make sure you check the second derivative. Okay. Other than that, we already wrote this stuff. Yeah, it's obviously one-dimensional. Okay, let's go. Let's move on to gravitation. Wait, I forgot. I asked it this or last night. Yeah, low-key glitched my chat out, bro. Gosh damn, bro. Alright, bro. I lost my... It's fine. Is gravitation. Bro, what is this, bro? Why do they do this? The hell? Well, what equation am I looking for? This one? I think that's not general, so like this equation she is kind of wrong. Well, it does say field per unit mass. guess I got all. Pretty sure I have that written in this one. Oh no, I don't. Yeah, I mean, I know them. They're here. This is really general, but that's just stupid. This is the very general as well. Equation. Yeah. This is only for a point mass. This is the general equation, where this is our volume. Okay, I need to go to the bathroom. Yeah, it's gonna write it stupidly that I know for a fact it's going to. Use premium version of ChatGPT? I do. My life would be way harder if I didn't have premium ChatGPT. Yeah, but our distance is like... Right, like that's way easier to understand, right? It's way more intuitive. Phi equals minus gm dm over r, right? Like that's way better, like a way better way of thinking about it. And then that also worked for this question as well. Like rho equals dm d tau. And then we solve the same equation. Oh, actually, we don't even use the same equation. Oh, mass enclosed equals rho d tau. Okay, this question's kind of complicated. I should redo this question. Yeah. Yeah, this is insane. Yeah. This question's actually kind of difficult. But I was able to solve it just using these like simple... Yeah, d tau for volume, area, length. Yeah, exactly. Yes, this is the most convenient master formula. See, ChatGPT is so stupid. Told you, bro. It knows nothing. And then I can just break it down into like volume, surface, line, and we have these simple formulas. You know how easy this is to integrate, bro? Well, actually, this one is kind of difficult. What is quad? Why are they adding spaces? Wait, lambda ds by r. Wait, why do we need a r? We need an r in the numerator, otherwise this integral is really hard to solve. This one's easy because we have r dr. No, r squared sine theta. No, that's volume. Area? What's area? Depends if you're in cylindrical or... I would just integrate the circumference over r. Yo, what's wrong with my connection, bro? Strange. I need to get my laptop Ethernetted, bro. No, it's fine. We'll do it later. Bro, please stop playing this song, bro. It's like YouTube music knows nothing about me. I hate that song. Field G. No, this is the easiest way to get G, little g. Or instead of integrating directly like that, you can integrate. You could use Gauss's law. Yeah, you have to use Gauss's law. Also use Poisson. Is that what I was supposed to do on that question? Homework 4? Homework 5? Yeah, but I just use Gauss's law for little g. Okay, let's write these equations, bro. I know. Dude, is my Wi-Fi tweaking, bro? This is decent. Okay. So our universal equation for gravitation, the most general equation that we can possibly have, is phi equals minus g integral dm by r by script r, where script r equals r minus r1, right? Like an example is just root x squared plus y squared. That's an example of what r can be. Bro, why is my music like cutting out? So for a volume in gravitation, we have dm equals rho of r d tau, rho d tau, and depends on what coordinate system we have. But d tau typically equals like r squared sine theta d theta d phi, right? So then we have phi equals minus g rho over script r d tau. Okay. Surface and this is like so analogous to Gauss's law, like, or to like magnetism and potential, which is why I think it's a better way of expressing it. It's more familiar to me. It's literally the exact same equation as electromagnetism. Electrostatics, I guess, is a better term. Yeah. Like I'm writing these from memory and I'm just making sure that they're right. It's so much better. And I'm gonna do lambda dr instead of whatever it's saying, right? Because I mean that's just like typically what we work with. Oh, dx. Fine. I'll write it dx actually. You can do r as well though, it's the same. It's just some distance. And it's arbitrary too. You set it yourself. Lambda over script over. This is gonna be dx, obviously. Okay. Additionally, for all of these distributions, g, little g, we did potential directly there, but like here, no, not here. Here we did little g first, right? But we used Gauss's law. Yeah, there's no point for me to write that out. Yeah, I wonder why in this exam question we didn't use Gauss's law, even though there's like insane symmetry, right? Oh, I guess it is Gauss's law inherently. You just skip a bunch of steps to get to minus GM enclosed over R, because it's a sphere. But actually, wait, is this question easier using Gauss's law? Okay, I'm kind of wasting time, but like, if you think about this actually should be easier in Gauss's law. Just make this small, move it somewhere else. Right, what's the question? Inside this sphere, yeah. So we're gonna have like, is gonna equal G for, wait, dA? Wait, this actually doesn't work. Right. Because this is gonna be M enclosed equals 4. Yeah, we're gonna be left with 1/3. Yeah, Gauss's law actually doesn't. Oh, you know what? Gauss's law is different. It's not actually M enclosed. Wait, what is Gauss's law in this thing? No, where's Gauss's law for? Because don't you have like an extra factor of like G and M opposed to like the normal Gauss's law? It's annoying. Why can't it just be like here? Yeah, here. Yeah, okay, this actually could work. Right, okay, and so we have a sphere. Oh, but then we're gonna have to integrate. Yeah, because our Gaussian surface is a shell with area, not volume. Right, we're gonna have G. Mass enclosed was 4/3 pi r cubed rho. So we're gonna get these. Oh no, it's the same. That's the same answer actually, I think. Gauss's law. And then we want to integrate with respect to r. Right, that's what we got, yeah, and so it's just like infinity to, oh, this is inside, so we actually have, let's just do the little one first. This is the same, right? 4 pi over 3 gr rho dr. Yeah, it's the same. So you could use Gauss's law. So is this just like a closed form for Gauss's law? Shortcut? Why are we doing shortcuts though, bro, when we could derive this so easily? Maybe one day you make an example. Okay. That's right. Let's finish this. Okay, so we have all of this. We already know this. This is like the easiest equation I've ever seen in my life. There's literally no point to write Poisson's equation because it doesn't even mean anything. Well, like it means something, but it's not like its own equation. It's just, or there's no point to write Laplace's equation because it's just Poisson's equation outside of a mass distribution. Like, there's no point to actually write that out. Let's also write Gauss's law. Where was I just now? Here. Yeah. So for any sphere, actually, it's going to be minus gm by r squared. Okay. Yeah, gravitation is going to be like the largest thing on my equation sheet. Okay, for a uniform sphere, for a solid uniform sphere, yeah, we'll just write the closed form. R is greater than equal to. I think that's kind of wrong, but it's fine. There's supposed to be a jump at the surface, but it's fine. We can just write it. Let's see. They're not going to ask about the surface on the exam, obviously. that should be right. Yeah. I actually kind of don't know where the 3 comes from, but I don't know where the 3 comes from, but oh, 3 over 2. Oh, because you have 3 over 2. Okay, so if you factor out the 1/2, yeah. Okay, I might not get that as yet. Over 3? What? Isn't it over r cubed? Oh no. It's over 3. 4/3 pi g rho r. Yeah. Wait, why do I not have this written here? Oh, I guess I do. Oh yeah, I do, right there. Okay. Okay, what else? Your finite line example, yeah. Yeah, it's a long solution. I hate that integral. Okay, what else did I just realize? Small town girl. Yeah, so if it's a star and they give us the density, right, you use the shell theorem. So you take the field of a singular shell, which is given by Gauss's law, and then you integrate that over R. And we know mass enclosed, but it's going to be rho d tau, but since our rho is dependent on R, we just write d tau equals 4 pi. We could just do a triple integral there, like it technically is just a triple integral. It's r squared sine theta dr d theta d tau, but d theta d tau or sine theta d theta simplifies to 4 pi. There's no theta or phi dependence. So you just get 4 pi r squared dr. But in either case, it's the same thing. Yeah, I should write that. I mean, everyone, like, that's just something you should know. Like, d tau equals r squared. And then in cylindrical coordinates, I don't really remember. D tau equals r squared sine theta d theta d phi equals dy dx dy dz. And then in cylindrical, what's d tau in cylindrical? R dr d theta dz. Let me think, does that make sense? Is that right? What's the volume of a I don't even know what the volume of a cylinder is. Pi r squared h. So yeah, theta goes from, yeah, dz is gonna go from 0 to h, right? So we just get h. r squared over 2. Yeah, okay, yeah. So you get 2 pi times r squared over 2 times h. Yeah, so that's right. R dr d theta d theta. R dr d theta d z. Oh, frick, I already messed it up. It's fine. Yeah. Rob, what's going on? Rob, you went to Berkeley, right? That's it. It's crazy that I don't remember that, but it's been a very long time, Rob. Yeah, bro, I was just there this summer. It was fire. I might go there for grad school, depending on a couple things. Exciting times. Yeah, Berkeley's a great place. Thank you, bro. It's crazy, bro. Rob has been here since like earlier it was like, okay, like it's not that big of a deal. It's only been a couple months. But now it's like deadass been like, how long is it? It's been 2 years. I've known Rob for 2 years of my life. 1/10 of my life, bro. Hopefully the food and the people were cool, yeah. They were super cool. The people there actually like were monumental, but the food was also fire. I was at the International House. You got engaged, bro. That's so hype. Good for you, bro. That's so hype. Okay, what have I not written yet? I already wrote this. Oh. Yeah. How do I not waste so much space writing this? I'll just write it here. For a sphere, r double dot equals gm by r cubed minus gm by r cubed little r. And that should be in the r hat direction, but I guess it's fine. We don't need to write it. Oh. Okay. Question 3. Orbit. Wait, orbit's not on this exam. I know that for a fact. iHouse food is fire. Yeah, iHouse food is fire, bro. People were complaining, but iHouse food was actually goated. And I also didn't have to pay for living when I was out there, so I didn't have to pay for the dining hall. Made it taste like 10 times better. It was so hype, bro. I got 3 free meals every single day. It was like the greatest experience of my life. Now I'm starving myself because I don't want to cook. I actually have to eat it. Yeah, free food always tastes better. Oh, I don't even have a fork. Guess I'm starving myself again. What's up, Alex? Oh, that's fire, bro. Yeah, no, I've DoorDashed, but I'm out of my Amex credit, so I stopped DoorDashing. It's funny. But I also live on Green Street, like, I can just go grab some food. I'm just lazy. Okay, I need to finish this equation sheet though, before like 10:45. So I have about an hour. Orbit's not on the exam. Oscillations, I mean, like, should we seriously write that? It's like almost no point. Drag models, linear drag. Okay, we actually should write some stuff for drag. This is for mass, time variant mass. Okay, so we have the thrust force is given by thrust equals m dot u, where m dot is dm dt and u is the exhaustive velocity. Mass decreases, so dm dt is less than 0 to mt equals mi, which becomes mf after a time t. Yeah, it's fun. For hovering, set f net equals to 0. For moving systems, set f net equals mdv dt. Yeah, this is very straightforward stuff. I really don't even need to write it. But I will. If I don't know, does YouTube take a cut? I don't think I have donations turned on. Please don't donate. If you want to donate, in the description, there's, oh, I actually should be like promoting this, but in the description, I have, I'm running the New York City Marathon for charity. So if you donate to me, that money all goes to charity, but I have to raise $5,000 to the charity to run in the marathon. So donating alleviates how much I have to pay to the charities. But the money still goes to charity at the end of the day. That's a much better way to donate. I appreciate that. I'm actually like not even close, so I need to I need to start promoting that. I actually forgot. I should have put it at the beginning of last stream. I gotta stream like a super long stream that'll get like a bunch of views and say it at the beginning. Oh, my Wi-Fi's lagging, bro. Do you drink energy drinks? No, I just have water. I drank a matcha like 3 days ago. Was that Monday? I drank, oh no, that was Sunday. Sunday? Yeah, I drank matcha on Sunday. That was the last time I had caffeine. That was my first time having caffeine in a while too. But it doesn't really change anything. The caffeine for me. Better put the fries in the bag? No, literally, bro. I've been scraping every dollar from my research to throw into this. Haha. Cafe Strata. Qualcomm Cafe, I'm pretty sure was in the basement of my building. Pretty sure. Okay, come on, bro. Okay, bro. Let's go to Berkeley. Qualcomm Cafe, yeah, Qualcomm Cafe. It's at Sitar Jedi, or Sitar Jedi. Yeah, that's where I was working. I was working at Sitar Jedi. So I would spend like 99% of my time at the lab. We were on like the 7th of Sitarja. 7th? Damn, bro, I don't even remember. But Strata, yeah, Strata was down the street from my house. So I would go to Strata sometimes. But I never really, I mean, I mainly just went to the lab. Bro, this is my whole life, this whole summer. So I would sleep at the iHouse. My room was right here, I think. Where's the parking lot? Can we get a satellite, bro? Yeah, this is literally my whole life. Okay, my room was right here, right over the trash. There was like a trash alleyway. It was like the worst thing ever. They were so loud every morning. It'd be like 5 a.m. They'd be throwing dumpsters all over the place. It's like the loudest thing I've ever heard. But I would go here, I'd wake up, I would come down here, I would run down to the RSF. That's what they call it, right? The RSF. Wait, this is the RSF? Yeah, it is. So I would work out in here, I would lift, and then I would run back up to iHouse, go right here to the dining hall. It's on the first floor right here. Go back to my room, come out here. I'd park on this street, and like the parking in Berkeley is so trash. I could park at night for free here, but then I had to pay for a student permit to park on campus. But the student permit was only during the daytime, so like I had to drive to work. Like I had to move my car. So I would drive over here, and then I would park. Wait, yeah, keep going. Right, yeah, Corey Hall. Yeah, so I would park here, and then they started giving me parking tickets because apparently you have to be faculty to park there. It's the stupidest thing ever. So then I would come and I'd park here, but there was no outlets here, so I couldn't charge my car. And so I parked there for like a month, and then I came up here and started parking all the way up here. And there's these electric vehicle chargers with solar panels. And then, bro, I don't think you understand. The walk to work was fine, so I would get out of my car up there, walk down here, and walk to my lab. But the walk back, bro, this hill right here and then up here, like this whole hill from here to here is like the steepest hill on planet Earth. It was the worst walk I've ever done in my entire life. And so I'd have to walk all the way up here to get to my car, and I had to move my car. Like, it wasn't even a choice. It wasn't like I was driving because I was lazy. Like, Berkeley would give me tickets. So I had to move my car and then drive all the way back to the iHouse. And that was basically like all I did every single day for most of the days. I didn't really do anything else. Sometimes I would run through here, like the whole campus. Actually, I did come down here a couple times to, I don't even remember what it's called, so I'm probably not going to be able to find it. There was like this place down, Rush Bowls. I would come down here to Rush Bowls, and I would get a acai bowl, but usually it was just a protein shake because I didn't have a kitchen, so I couldn't make protein shakes. And so I would go down there and buy protein shakes. I didn't really do anything else. I mean, I had family up there, so I'd go hang out with my family, but other than that, I was basically just working all day. I had too much going on. I had like 3 jobs, bro. It was fire, but also like a lot of work at the same time. Or 4. Yeah, 4 jobs. Yeah, that's like literally my whole life. That was literally my whole life. The whole summer. That's what I did every single day. Okay, I missed a lot of. Satarja die. Satarja is your friend's dad, bro. Wake up to the sunrise view in the morning. Day in the life of AI Berkeley researcher at Apple Maps, literally. Soda Hall, bro. Soda's trash. I'm not gonna lie. But thank God they're building that new CS building, so it's chill. Soda and bro, Corey is ass. Corey has some great professors in it, but Corey, like the building itself was terrible. It was so bad. That street is like a 45-degree ramp, bro. It's insane. I would. Bro, it was actually some bullshit because I would get the electric scooters to try to make it like an easier walk. And so I would like scan the electric scooter, and then I'd try to go up the hill, and I swear, like, I'm not even trolling, the electric scooter would start rolling back down the hill. It didn't have enough power to like overcome the incline, like genuinely. So I'd have to get off the scooter and walk. Like I couldn't, it was like they made me walk up the hill, like no matter at all costs, like I had to walk up the hill. There was no getting around it. It was so trash. Haven't you long surpassed classical mechanics? Yeah, the original, like part 1 of classical mechanics, but now we're in like Newtonian mechanics and just more complicated stuff. So, you know, air resistance, drag, things that you neglect in normal mechanics. Tell me about Faraday's laws. All right, bro. 4 jobs. You had 4 jobs. Yeah, I was working, so I can list them. I was doing research at Berkeley. I had an internship at this company called Bright Tech. I was doing research at UIUC still. And then I was working, I'm the CTO of a startup that one of the professors that I used to do, or I still do research with him actually, he spun the research off into like a startup and he hired me as the CTO. And so I was doing that. The hours were 40 hours a week Bright Tech, 20 Berkeley, 20 CTO, 40. And then I guess it was like, I mean, I was getting up to like almost 20 hours with UIUC too, but I would say maybe less than that. But UIUC and the CTO position had a lot of overlap. A lot of the work was overlap. So like when I say 2020, it was like a lot of it was combined. So probably like 30 hours in total, like 30 distinct hours. So how many? 30, 40, 20, yeah, that sounds right, I think. Yeah, so I was pretty busy most days. That's why my life was like the same thing every single day. Bro, Corey is a prison, literally, bro. Let's fire Sebastian. Yeah, my scooter didn't do shit. The inside of the gateway is insane looking. Oh yeah, that's where the professor that I was doing research with this summer, she's moving there to the gateway. My scooter were my legs. They gave you a stipend, right? Yeah, they did. Are you considering starting a startup? And are you pursuing a master's? I'm gonna do a PhD. I don't like the term startup. I do want to start a company, and I guess it's going to be a startup in the early stages, but I feel like startups have life cycles, and I want to build a company that doesn't have a life cycle, you know? Something that lasts forever. It's idealistic, but, you know, that's the goal. When learning all day long for years and working hard. Bro, that... I guess it's kind of just like a personality thing. Like this statement to me doesn't even make sense. Like getting depressed when learning all day long for years and working hard. Like those things are mutually exclusive in my mind. I think learning all day long for years and working hard every single day makes me happy. So it's actually like the opposite. So I think it might just be a personality thing, I don't know. When I was at Berkeley, there were so many protests, and the Amazon store got flashbanged. What? There was like surprisingly no protests this summer, even though there was all like the Palestine stuff going on, and you know, Ukraine. There's like a bunch in Trump. Oh yeah, there were some huge Trump protests, but they were not on Berkeley campus. Yeah. But my dad told me stories that when he went there was all sorts of protests, like when they were building the stadium for the football team, that they had to like build on top of some Native American burial ground, and so like a bunch of, well, not Native, I guess they're Native Americans, but I don't want to be like racist, but a bunch of people who were supporting not building on top of the burial grounds were like camping in trees. Like they made tree houses. And some guy, I think he like set a world record, but he lived in a tree, like on the construction site. He built like a house in the tree, and he lived there for like 6 months, and they couldn't do anything. Like they couldn't build because he was living in the tree for 6 months. But then they finally got like some warrant or something, and where it was able to like evacuate him or something. And then they built the stadium right on top of the Native American burial ground. Have you done this equation sheet? No, I'm not done yet. I still have to do time variant math. But I got distracted by chat. PhD in what and who do you look up to in terms of CEOs and whatnot? Honestly, don't really look up to anyone. I mean, you're really not supposed to like idolize anyone, right? If you're religious, and that's what we're taught. But I mean, everyone is good to look up to in their own right. You know, you can learn anything from anybody. So like, I mean, a lot of CEOs, I don't have respect for some of the decisions that they make, and I don't agree with what they say holistically. So I wouldn't say like overall I look up to a single CEO, but there are certain people who have like great traits. Like Sam Altman is really good at telling people what they want to hear, which is a good trait to have. Demis Hassabis is, you know, a pretty good CEO to look up to. But again, like I still disagree with some of the things that they do or have said. So I wouldn't say I like look up to them in general. I mean, even Elon Musk, someone who I have very little respect for, intellectually that is a wonderful businessman. Like he's a terrific business person, and can be admired in that sense. But I wouldn't say I look up to him, of course. Last year, the gate was blocked every day. Yeah, it's crazy, bro. Berkeley doesn't play. When did you leave Berkeley? I left August, like 20-something. Literally, like I flew straight home, and then I like packed up my stuff and went to school. I had no summer break. I had a very short summer break. Okay, so at the beginning, right after finals, I flew to Japan like 2 days after finals, and before finals had even started, I had already started my job with Bright Tech, but it was just onboarding and stuff, so it was really light. And so I was working my Bright Tech job while I was in Japan, and then I also briefly like did some background into my research at Berkeley, but it wasn't like work really. And then I didn't get hired as CTO until halfway through my Japan trip. So that first like 2 weeks of being in Japan, I got a good summer break in. I was only working like 40 hours or something. So, or actually it was early in my internship, so maybe I was even working less than 40 hours. So it was really like a really chill break. It was really, really fire. But going straight from like working 90 hours a week and then just coming straight to school was kind of trash. I'm not gonna lie, I low-key wish there was a little break. But when school started and I stopped all my jobs, school was really light at the beginning, like syllabus week and stuff, so that was kind of a break as well. Are you 23 teaching yourself calc and trig? Bro, I'm pretty sure like 90% of the world does not know calc and trig. Oh, actually that might not be true because of India and China, because their population's so high. But I mean, if you live in the United States, I would say probably 90% of United States citizens do not know calc and trig. So learning it at any age puts you above average, right? Musk is a CEO cutting costs. I mean, you have to cut costs in business. That's not something I disagree with him on. But a lot of his moral decisions I don't agree with. That's it. There's no point to talk about it. I mean, that's a whole conversation. Right now, Sam Altman is the best CEO. Well, I actually don't think that's true in any aspect, right? If you're talking about the best CEO economically, it's obviously Jensen Huang, right? His company in specific, NVIDIA, is like doing incredibly well. Or Elon Musk. I mean, his personal economics are insane, right? I mean, he's the richest man in the world. Same with Larry Ellison. You know, all these CEOs are better economically than Sam Altman. And then when it comes to AI, honestly, like being an AI CEO, Sam Altman is also not the best. Like Demis Hassabis is better. Dario Amodei. I think Dario Amodei is the best AI CEO. Like when it comes to like AI innovation and stuff. I guess Sam Altman is a good CEO in the same way like Tim Cook is a good CEO. You know, the product vision is definitely there, and that's what's really pushing ChatGPT is like they have the product vision and the branding. So I guess he could be, but then again, like Tim Cook is better than him at that. Like Apple is the king of branding, right? So Sam Altman's a good overall CEO, but I don't think he's the best. Are you gonna do a PhD at the time? Currently, I am gonna pursue a PhD, but we'll see what the future holds. I'm gonna do a PhD in AI applied to robotics. You seem to actually enjoy school. What a loser. Yeah, I get that a lot. No, I'm just kidding. Let that sink in. What sink? Okay, that my fault. My fault, bro. I'm just gonna get back to studying. Just stop talking. My fault. But let what sink in? I don't even know what you're talking about. Okay, time variant mass. What was I saying about time variant mass? Oh yeah, rocket motion, time variant mass. There's really nothing to write here, like F thrust equals m dot u. M dot equals dm dt is less than 0. What else do we have? F net, yeah, for hovering F net equals 0, no acceleration. I mean, that's like just common sense. I guess we can write m of t because I did forget that when I was doing the homework. M of t equals mi plus dm dt times t. Yeah, if it's hovering, obviously we have no acceleration. If it's accelerating, then we have ma equals F. We just use Newton's second law. Right. Okay. That was there. So small oscillations. Should we write that? I mean, we can. We can write. Okay, fine. We'll write oscillations. Oscillations. Does that have one L or two? Two. Yeah, there's no point to write that. We can write this Taylor series, I guess. Okay, whatever. I'll just write this. Like, it's pointless. I already know this stuff, but we can just write it. I have space. I have empty space on the sheet, so. Okay. I guess we can write these two equations because we need them. Root m over k, or k over m. T equals 2. Okay. Equation m a equals minus k. What is that? Okay, I guess we can write that. U double prime x naught equals equals k. What is mk double dot, or mx? So that's ma. Well, what does that equal in log? But this pen is kind of drying up, bro. X minus x naught. I don't know what that is. F equals minus grad u. Grad u is just going to be the first derivative. That doesn't make any sense. Oh, first, no. Oh, I guess you're doing first derivative of x plus x naught. Yeah, I don't know what that's about. And also, I got x plus x naught, bro. Right? Didn't I? Oh no, x minus x naught. Oh, we're told it's x minus x naught. I think you can also do that for x plus x naught. It's just any perturbation. Okay, drag. Okay, fine, we can do drag, yeah. Drag. The force of drag equals minus CV. We're told that anyways, though. So, mv dot equals mg minus CV. Yeah, f external minus CV. mg minus CV typically. Quadratic drag. Okay, fine. Wait, squared. Minus BV squared. Is that from downward plus terminal speed? mv dot equals mg minus bv squared. Terminal speed is mg root b, or mg over b. Damn, bro, what are they doing upstairs, bro? These people be stomping all day. But what are their feet made of cinder blocks, bro? Oh, it's an Elon Musk Twitter reference. Ball knowledge. Damn, bro. Oh, is that when he made that, like, stupid joke? Damn. Elite ball knowledge required. Is classical or quantum mechanics harder? Huh. I don't know. They both seem... To me, they were both pretty straightforward. I think, like, quantum mechanics 2, which is the equivalent of, like... This is classical mechanics 2. I'm pretty sure quantum mechanics 2 is significantly harder than classical mechanics 2. But classical mechanics 1 and quantum mechanics 1 are pretty straightforward, both of them. Hey twin, where you been? What's good, bro? Hate those kind of neighbors. Assalamu alaikum. I just finished Vagabond. Malaikum salam. Space-dependent solution form. Drag is dependent on proportional to v squared and use dv dt equals v dv dx. Yeah, separable and x. That's easy. Okay. Free fall. Okay, terminal. I didn't know terminal velocity was so easy to solve for. Wait, what's the point? Free fall with quadratic drag? Wait, that actually is hard to solve. That's not linear, that's not separable. Wait, that equation is actually, drag is actually hard to deal with. Mach 3 probably. That was easy. Oh, phi dot equals omega. I should actually write that. Oh, and tan theta equals r phi dot over r dot. Right, we're given r dot in this equation, right? Yeah, that's how we do anything. Yeah, you just set r equals big R. Yeah. Okay, wait, actually, if I didn't write down phi dot equals omega, if we got this question on the exam, I would have been cooked. Because I wouldn't have known what to put for phi dot. Okay, but continue. Where's the one where we had to do separation of variables? Oh, this is drag. Yeah, isn't this not linearly separable? dv dt equals... Oh. Oh, no, it is. Wait, but this one... Oh, yeah, because G and V... Okay, yeah, never mind. It is. It is. It is linearly separable. Yeah. Okay, it's linearly separable. That's how you do that. Yeah, so... Yeah, but we never even use quadratic drag. Yo, is this answer in the simplest form, you guys think? That's how bored I was when I was studying, bro. I was just writing random numbers. That's so stupid. Yeah, this doesn't have quadratic drag either. This is like the easiest question I've ever done in my life. Yeah, but you don't treat m as a function of time there, because the dependence on time is captured by the integral. Okay, mi at t is m at t equals 0, mf is m of t at t equals t. dm dt u equals minus, yeah, okay, that's easy. Wait, how come you don't do dm dt here? Oh, you do. Not. Because you're integrated with respect to v. I guess it depends on what you're trying to find. Time or velocity. Okay, what did I want to do? What was I writing? Oh, terminal velocity. Okay, I'm actually going to write this down. Oh yeah, because I need to write the cross product and stuff. Okay, I'm gonna write this down though. I'm gonna write this down. I'm gonna say okay, so I'm gonna put terminal velocity. Okay, I'm gonna put it with FD equals. mg by b. Okay. And then I'm also gonna write, I wanted to write like dm dt minus okay, and then the next one was this one. And we said and then that's linearly separable, obviously. You just divide by m. Oh. Yeah. Oh no, it's plus. It's plus. Wait, that's, oh no, that is drag. Okay. Okay, quadratic drag. B equals root mg over b. Nice. If it's not quadratic, it's just mg by b. Rigid body, projectiles, strategies, coordinate helpers. I need the coordinate helpers, so that's the last thing, and then I'm done. So I need divergence, that's spherical. Laplace, spherical. That's ridiculous. I'm low-key not writing that. I need cross product in both. I need cross product and dot product, or not cross product, curl and divergence in both. Where's my arc? Okay, let's just get like a cheat sheet. Oh, you know where I already have a cheat sheet actually? Is physics 435 equation sheet. Perfection. And, oh no, but they write it in a stupid way, bro. Right? Don't they say, oh no, they don't. Wait, what was the problem? I had a problem with how they wrote it, actually. Bro, this is OD, bro. We'll definitely need the curl, like, in spherical. Bro, this is so much writing, bro. What software? This is QuickTime connected to my iPad. So it's just my iPad screen with Notability. Will you take statistical physics? I actually don't have to, because I already took stats. I took stats and I took a CS class that covers like a little bit of statistics. And all my machine learning courses have been like just hella statistics. So. But I'll be right back. I need to grab a fork. Just remembered how much of a pain it's going to be to write all these equations. Unbelievable. Alright, bro, it took me that long to write just the spherical coordinate ones. Luckily, the cylindrical is shorter, but still. Oh, that's why I didn't like these ones, because they use S hat instead of R hat. Yeah, I use R theta Z. They use S phi Z. Fine, I'll leave it in S just so I don't mess it up, bro. That's why I don't like these ones, bro. Luckily though, they're much shorter. This is cocked, bro. are cylindrical why are spherical coordinates such a pain, bro? It makes our lives easier, but at what cost, bro? At what cost? Look at the curl, bro. Oh, frick. Keep doing that. Messed up a little bit, but it's okay. Let's go, bro. Finally done with this nonsense. Almost. Okay, let me also write the. Oh, crap. That's annoying. Do you know the story of Jared Kaplan? I've heard of Jared Kaplan. Do you struggle? Did you struggle? Oh, did you struggle? I mean, not really, but that was because I was forced to. Like, I didn't wake up and choose to like study long and consistent hours. Like, I'm forced to. Right? I mean, I have goals, and my goals require certain things, and those things, especially right now, like getting a high GPA or getting good scores on exams, require me to do that. Like, it's not a choice. Like, the first time I ever studied long was when, after I'd failed my first calc exam. I failed my first ever exam in university. And then I had to lock in. I got like 90s on all the other exams, which at the time was a good score for me because I failed the first one. But, I mean, 90's really not that good in my brain now. But I just studied really hard to make up for that. And that's kind of where everything started. Calc 1, yeah, Calc 1. Such an easy course. Like, I could literally ace that exam right now without studying like a single second. And I got like a 50 the first time I took it. It's crazy. Crazy world we live in. I ended up getting like hundreds on all the exams in Calc 2 and Calc 3. But still, Calc 1, I failed the first exam. The first exam is the easiest exam. The class average was like an 89. Yeah, bro, it's because once you get your first 100 midterm, like actual midterm exam, and you get 100 on it, then it's like you can't stop. Like, I think my first one was first semester sophomore year. And like ever since I got that one, like I've gotten hundreds on like a bunch of midterms. And it's just like, if I don't get 100, it's like, it's bad. Like this semester I got like a 92 or something on my first chem exam, and I was like tight. I was like not happy. I was not happy. This physics stuff's a little different, like electromagnetism, I'll be happy with a 90. I'm not gonna lie. But like the easy courses like Lin-Alg, Diffie-Q, quantum mechanics, thermal physics, all of my CS classes, those classes, it's like I can't. If I get less than 100, it's cooked. Oh yeah, no, I knew, and Dario Amade also studied physics. They were both physicists. I know they were both physicists. It's very common for physicists to get into other fields. And ML being such like a prominent field in AI, you see it very often. I mean, the founders of this company called, I don't even know what it's called actually, but they're physics majors. The two founders of Anthropic were physics. I think maybe like what's his name? Geoffrey Hinton was physics originally. But, I mean, he's a dinosaur, so that was a long time ago. I think Geoffrey Hinton was physics. Does he not have LinkedIn, bro? Oh, he was switching around fields. Yeah. Okay, Jeffrey got a bunch of different types of degrees. What, physics majors? Well, it's not like something. It's not like physics like teaches you to do other things. I think it's just that physics teaches you, one, math. Like math is a big part of physics, so I mean the math is super analogous in AI and any field, any engineering field. The math is like the cornerstone of everything. But also just like thinking from first principles. And I think everything like kind of built, like all engineering disciplines really build just off of physics. So it's pretty easy to transition from physics to one of those domains. You gotta think, if you're able to do like quantum field theory, bro, alright, like AI is gonna be easy for you, bro. Like just study like a couple hours and you'll know. You're failing quizzes? Yeah, I wouldn't do that. Yeah, I mean, personal projects and portfolio is like instant gratification, right? Like you build something cool and you see it immediately. And so it's easy to be like, okay, this is better than school because, you know, you're learning practical skills and you see immediate results. But I think long term, like the information that you learn from your degree, the skills that you learn studying, the character traits that you develop, you know, being an above average student are much more valuable long term than any short term thing from a project. And there's obvious exceptions, right? Like Mark Zuckerberg's projects, right? Like those are exceptions. So you do have to weigh it to see, like, you know, is this truly net, like in my whole life, is it net better than, you know, university, more beneficial? But oftentimes it's not, in my opinion. So the highest level of math, you know? I mean, I can just go through all the maths I've taken. I've taken Calc 1 through 3, linear algebra, discrete math, differential equations, statistics, biological math, or it's like modeling of biology and math. It's a pretty interesting course. I think I'm gonna take like real analysis next semester. But yeah, I mean, I'm not too high up in math. I'm sure I'm missing math classes that I've taken, but who cares? Okay, I need to write these. Should I write the coordinate vectors? Do you think that's gonna be useful for the exam? Bro, that is so stupid. Bro, look at the spherical coordinate vectors, bro. I low-key like can't write all that out. I'm so serious. Yeah, there's no way I'll need those on the exam, bro. Let me so real. I guess I'm just lazy because I'm not writing that. I swear to you, I'm not writing it. This is my equation sheet, bro. You get a full page, but this is all I got. Oh wait, what camera are we on? This camera. This is all I got. I got nothing else to write. But also, so on each individual exam, you get a full one side of a piece of paper. So if I only fill half on this exam, then the next exam I'll fill the other half, and then on the final you get 2 full pages, and so or like both sides. So I'll just fill the back for the final. So half for each midterm. I'm doing the same thing in my other physics class. I didn't fill the whole equation sheet. It just wasn't necessary. Yeah, I think I'm done with this equation sheet, bro. I don't think there's anything I'm missing. Let me look at this. Yeah, I got it. It's not necessary, it's not on this exam. Did that. I don't even know what this is. Like, genuinely. I don't even know what rigid body is. Rigid body, bro. L equals I omega. I don't even know what I is. Yeah, no, that's not on my exam. Projectiles. Bro, that is literally physics 211. I'm not writing that. If you don't have these equations memorized, you're cooked. Conservative 1dV equals this nonsense. Wait, how'd they get V equals that nonsense? This is for conservative or sing conservative? I guess I can write it. Easy enough. V equals 2 by M E minus UX. Okay, easy enough. I guess we can write T as well. T equals root dx by v. Or not root, integral. Coordinate helpers, yeah, I wrote that. F equals F, I guess I can write that on there. F equals F of R, R half. then grad.f, we don't have to write that because that's just down here. Well, actually, I don't know if it's spherical or cylindrical coordinates. Actually, it might be the same. 1 by s. Oh no. Oh yeah. Oh, s squared. R squared. Wait, is it s squared? Yeah, it's r squared. So it's spherical. Spherical coordinates. Okay, let me write that. Grad.f equals 1 by r squared. dr of s r squared. Laplacian. Alright, done. We're done with the equation sheet, bro. I can't even think about writing anymore. I gotta put this in my backpack so I don't forget it. Have I ever tried solving international math Olympiad? Oh no, physics Olympiad questions? No, I haven't. I'd probably get cooked. But it just hasn't ever been of high utility to me to do something like that. It's very interesting, honestly. I think it's very interesting. I would love to do it, but it's pretty much a complete waste of time for me. None of my current goals involve, being a physics Olympiad. Well, I guess that's stupid because none of my goals require me to be good at chess. Not saying I'm good at chess, but I do practice chess a lot, so I guess I just never did it. Let's play some hype music, bro. I'm about to end stream in a split second. Oh, that's not hype at all, but this song's fire. You know what, maybe I'll end stream right now, actually. I mean, we had a 4-hour stream. That's decent, right? You enjoy research right now? Not going the CS track? Yeah, I'm enjoying research a lot. So, hold on, I can't talk while I'm listening to this music. I enjoy research a lot right now. That's why I'm pursuing a graduate degree. That's why I'm 1, pursuing a graduate degree. And 2, doing so much external research right now. And 3, not doing a double major that I was gonna do, the CS plus math double major, because I want to graduate. I used to really enjoy just schoolwork as a whole, but I've become increasingly disinterested. I still value my schoolwork and, as I've said, the character traits and stuff and the skills that I build doing my schoolwork, but it's becoming increasingly less interesting to me. And so I'm trying to graduate and go to graduate school to do research, because research is really interesting to me right now. Yeah, exactly.
there are far more important things that I personally like want to work on. But of course, like my goals are my goals still, and so those come first. And so school, unfortunately, has to come before all else right now. You know, when I have exams, that's the only thing going on in my life. Besides for work, like I still have to have an income, but yeah. Daily battle indeed. The other day I was just thinking like I should just drop out. No, I'm joking. Not really. But it would be nice, you know, like being able to just work on like stuff that you want to work on all day. But where's the character development in that, bro? You working in CS? Yeah. I'm doing I have a CS job, and then I also have a CS research position that is paid. So curious to how your grind was to get a job / internship. I didn't really grind at all, specifically to get a job. I grinded in life in general, and then the job kind of just fell into my lap. Like actually, genuinely, I only applied to the Berkeley research program. I ended up fortunately getting it. And then the internship that I had was because I built that startup last spring. And so I didn't even apply. I didn't even have to apply to that job. And then my other jobs were just, also I didn't have to apply. My research from UIUC, okay, I did have to apply to that. Or not apply, but I did kind of grind for that. I emailed a bunch of professors at the beginning of last school year, and one hit me back and gave me a research position. But then from my performance in that research position, I was given a job that I had over this summer, and I still have currently. Yeah, and that job was, yeah, again, not a result of any, you know, job acquisition grind. Any technical interview? Yeah, I mean, I've done technical interviews before. A couple of them. Like literally only a handful of them. I've passed all my technical interviews actually. Which is interesting because I don't really prepare for technical interviews. But at the time that I did the technical interviews, I was taking all those courses that they like CS 225, 124, 128, where you learn like memory, linked lists, you know, just binary trees, binary search trees, B trees, heaps, stacks. Yeah, like I don't know any of that stuff anymore. Hash maps. So I was at a disposition to get those questions right. Yeah, technical interviews suck. I plan on not doing any more technical interviews for the rest of my life. You know, I mean, I'm going into research. You don't have to do technical interviews. Well, you do have to do technical interviews, but not like the stupid CS ones. Those ones are actually fun. Like they ask you like research questions or questions about research that you've done. And of course I know how to answer all those questions. And then after you get a PhD, like you don't have to do technical interviews again. You're well beyond that. So would you recommend cold emailing a bunch of professors at your university to get a research opportunity? I think that's the least effective way of doing it. That's how I did it. But also like programs, there should be research programs at your institution, like that you can just apply to, or honestly, some of them you can just sign up for. They're not even, because they're not paid programs, so you just sign up for them. Like my class, or my school has classes that you can just sign up for. That's it. All you have to do is sign up for it, and it gives you a research position, and you get credit hours for your research. and then you can continue that research after the semester or the term is over. That's the easiest way and most effective, because all you have to do is sign up. There's no contingencies. But cold emailing is probably the best way, because you can ensure that the research that the professor is doing actually aligns with your personal interests. But in terms of actual research position acquisition, it's the least effective, by far. I emailed 20 professors. One responded to me 3 months later. 4 months. It was actually insane. I thought he'd forgotten or just ghosted me. Most of them ghosted me. But it's because their emails are so flooded. It's not because they're intentionally. Well, actually, I don't know. Could be intentional. Who knows? Good luck for that quiz tomorrow. Well, I have an exam in 56 minutes. I don't have a quiz scheduled for tomorrow. I do have a chem quiz that I can take tomorrow, but I have it scheduled for Saturday. But nevertheless, thanks for the good luck. Yeah, 225. Yeah, that course is fire. My second year coding course. Yeah. Oh, that was our third year coding course. Second year. Yeah, third semester. Yeah, second year coding course. Yeah, the same. We had the same. Yeah, I mean, you're obviously going to feel behind for technical interviews if you haven't taken that class yet, if you haven't taken second year CS classes yet. But I feel once you take those classes, if you do well in those classes, bro, our exams were, I had taken technical interviews before I took the class, and our exams were literally verbatim technical interview questions. Our whole exam, the whole entire exam. There would be some conceptual questions that, it would suck if you got those on a technical interview. But the coding questions were literally straight up, reverse a linked list, or search a binary tree, or search a binary search tree, or reorder or something. Min heap implementations is literally exactly technical interview questions. Which is why technical interviews were so easy after that course. Are you gonna stream tomorrow? Tomorrow is the best weekday for me to stream schedule wise, but I just came off 3 exams, so I'm probably gonna rest tomorrow. Well, no, I'm still have schoolwork and stuff and work to do, but so I'm not really gonna be resting, but it's gonna be much chiller than what I'm doing right now. Or I guess I'm not doing anything right now, literally right now. How old are you? I'm 20 years old. I'm gonna be 21 in January of next year. So look out, world. I'm gonna be 21. It's so great. Turning 18 was more monumental than turning 21. And turning 18, literally nothing changed in my life. So I don't even know what's gonna happen when I turn 21. I guess I can own a firearm. That's it though. And I get they switch the orientation of your ID. But other than that, nothing changes. Locking in on what does that even say? Oh, I got so focused on math. Well, you should focus on both. Doesn't have to be equally. Whatever is required to get a good grade. You still balancing athletic side of life? Yeah, I am, but I'm not a college athlete anymore. Dude can now drink SMH. Yeah, I can. Legally, I guess. I can drink now. I don't, but I guess, I don't know. Yeah, that has no consequence on my life. Do you read latest ML research papers? Can you understand them? Can I understand them? No. Do I read them? Sometimes. I'm mainly reading robotics papers right now, VLAs, stuff like that. It's all on my website, my reading list. But I can understand them overall, but you know, the nitty-gritty stuff, obviously. I mean, you need to be a PhD or a master's student in the same field to even begin to understand. Like this summer I was reading research papers that were literally like doing the exact same stuff that I was doing for my research, and when I did it in my research it made sense, but when I read their research papers it did not make sense. And so like, yeah, I mean, it's really different. Research papers are really hard reads. You know, it's not something you just like understand when you read it, but you can understand them if you study them enough. And I mean, if they're doing like literally the exact same thing you've been doing for maybe years or something, then you could understand them, you know, just from a skim. It's how the professor was. She understood all the research papers. It was insane. And so when I brought up papers, I was cooked if I didn't know all the facts about them, which was good because it made me have to study them, but it was very stressful. Love from India. Aspire to be an AI engineer next year. I'm going to do my undergrad. That's fire, bro. Keep it up. All right, I'm ending stream because my exam's in 51 minutes. So goodbye. Please donate. And down below, donate to my. I'm running a marathon, New York City Marathon. All the money goes to charity, but I have to raise a certain amount of money to be able to race, and all that money goes to charity still. I have to raise that money and donate it to charity, but I have a link that helps you support me in supporting the charities. So you are directly donating to charities and then indirectly helping me run in the marathon, because I low-key can't afford it. So please donate. High-key, I high-key can't afford it. Well, it's actually more low-key, but I don't want to pay that much money. I mean, it's a charity, so I wouldn't be that upset, but all the help is great. Thank you. Please donate RTX 5090. I'm buying an RTX 5090 already, so I guess you could donate one, but I'm going to have one. But what's up, Chippy? I'm ending stream. If I wasn't ending stream, I would stay and talk, but I hope you're doing well. Goodbye.